Hello friends, welcome to Electrical Circuits. In this video, we will see Thevenin's theorem. We will learn the process how to solve circuit and also practice on numerical based on Thevenin's theorem. Before starting, let's do quick revision. If you had not watched previous video, kindly click above. In previous video, we have gone through Kirchhoff's current rule. We have seen the nodal analysis. We had also practiced on numerical based on KCL and nodal analysis. So now, let's get started. We will start with definition of Thevenin's theorem. Thevenin's theorem states that any linear complicated circuit can be converted in simple circuit with having only one voltage source and one series resistance connected to it. Friends, here we need to focus on term linear circuit, as this theorem can only applicable on linear circuits. As suggested in definition, single voltage source is known as Thevenin's voltage source, and that single resistance is known as Thevenin's resistance. From this figure, concept of Thevenin's theorem can be understood nicely. Here, VTH and RTH are Thevenin's voltage and resistance respectively. But now, question is how to find that Thevenin's voltage source and Thevenin's resistance. So let's assume a simple circuit with having two loops. Here I am considering RAB as a load resistor and I want to find current and voltage drop in that resistor. It could be found by many techniques and some of them we had discussed in earlier also. But friends, here we gonna use Thevenin's theorem. This circuit can be simplified like this using Thevenin's theorem. Let's understand the procedure of reducing circuit stepwise. Friends, we are having main two tasks. One is to identify Thevenin's voltage and another is to identify Thevenin's resistor. So here we will start with Thevenin's voltage. Thevenin's voltage is potential difference between load resistor when load is not connected. Some steps should be followed in order to find Thevenin's voltage. Here, step 1 is remove load resistor and redraw the circuit diagram. In step 2, we are gonna calculate the terminal voltage across the load, which will be further known as Thevenin's voltage. Friends, terminal voltage could be found using any techniques such as KVL, KCL, nodal analysis, source transform, source conversion, and many more. It could be selected as per your proficiency. But here we are going with KVL. Now let's assume I current is flowing through loop, and from the loop equation we can find the loop current. Once the loop current is found, voltage across the load resistor could be identified using Ohm's law. In our case, it is 13.33 volt and it will be known as Thevenin's voltage. Here, first portion is completed. Now we are moving towards finding RTH. Thevenin's resistance may be defined as equivalent resistance between load terminals when all the voltage sources are short circuited and all the current sources are open circuited. In order to find equivalent resistance, there are couple of steps that should be followed. Step 1 is remove load resistor and redraw the circuit diagram. Friends, step 2 is again very simple. In this step, we will short all the voltage source and will open current source. Then after, circuit will look like this. In the final step, we need to find resistance between terminal A and B. Here we can see that both the resistors are connected in parallel combination. Hence, equivalent resistance will become 6.67 ohms. It will be known as Thevenin's resistance. As we have calculated VTH and RTH, now we can modify this circuit by 13.33 volts voltage source and 6.67 ohms series resistance. Load resistance, which we had removed earlier, is supposed to be connected with new combination. Finally, it can be seen that two-loop circuit has now converted into single loop. By using KVL loop equation, current through load resistance could be found. Here, in our case, it is 0.286 ampere and voltage across this load resistor is 11.44 volt. Let's make concept sharper by another example. It is seen that 3-loop circuit with having one current source. Here I am going to find current through load resistance and voltage across load resistance. So calculation for VTH is as follows. First step is remove the load resistance and redraw the circuit diagram. Now after redrawing the circuit diagram, we need to calculate voltage across point A and point B. Here VAB is nothing but potential difference of node VA and node VB. Friends, in previous sum, we had taken KVL in order to find Thevenin's voltage. Now we will go with nodal analysis. Here current I1 is entering to the node while I2 is leaving the node, and there is no current in I3 as branch is disconnected. Now node equation can be written as mentioned. After solving this equation, we can have VA equal to 6.67 volt. Same as node A, we can apply node equation at node B too, and we'll get -9 volt at node B. Here Thevenin's voltage is potential difference of VA and VB, so it will be 15.67 volt. After finding VTH, now in this portion we will find RTH. In first step, we need to remove load resistor and redraw the circuit diagram. After completion of this step, we need to short circuit all the voltage source and open circuit all the current source. So circuit will look like this. Friends, in this last step, we need to find equivalent resistance at point A and point B. Here it can be seen that 1 ohm resistor and 2 ohm resistor is connected in parallel and another 1 ohm resistor is connected in series. So after solving, we are getting 2.67 ohm as RTH. Friends, here we can see that how 3-loop circuit is converted in single loop circuit, with having 15.67 volt as a Thevenin's voltage and 2.67 ohm as a series Thevenin's resistor. After connecting load resistor to Thevenin's combination, we can find current through 1 ohm resistance and it is 4.27 ampere. While voltage across load resistor is also 4.27 volt as our load value is 1 ohm. After getting know about Thevenin's theorem, it can be summarized as it is one of the circuit solving technique by which we can find current through load resistor. Basically, in order to perform Thevenin's theorem, we should follow some steps. First step is remove load resistance. After that, find VTH using any circuit analysis technique. Then after, find RTH by shorting voltage source and opening current source. Finally, we'll get load current. After attending this session, we came across Thevenin's theorem. We get to know about procedure to solve circuit using Thevenin's theorem. We also did numerical practice based on this theorem. In upcoming video, we will learn about Norton theorem. We will solve numerical based on Norton theorem. Stay tuned for upcoming video. Kindly do like, share and subscribe this channel. Press the bell icon for regular updates. Thanks for watching.